Okay, everybody, I want to welcome you back to another gripping episode of Subnetting with Professor Bridgehouse. Just kidding, it's not really gripping. So, in today's exercise, what we want to do is we're going to go with a scenario, okay, and determine how we're going to subnet that scenario so that we can then apply it to our routers at a later date. So, we're going to look at the first problem on this worksheet. I'm going to do this one with you, and then you guys are going to go ahead and complete the rest of the worksheet on your own and submit it to me. All right, so first, let's look at the background, okay? A subnetwork or a subnet is a logically visible subdivision of an IP network. The practice of creating networks is called subnetting, okay? All computers that belong to a subnet are addressed with a common, identical, most significant bit group in their IP address. This part of the address is known as the routing prefix or the routing number. Okay? The size of the routing prefix may be indicating uses something called CIDR, C-I-D-R, which is our class of interdomain routing number. Okay? It's derived from the total bit count of the subnet mask, or the subnet the network numbers and the subnet numbers. Now, what we're going to do at the completion of this is you're going to be able to correctly create the necessary subnet mask for a given number of subnets and hosts per subnet. Correctly calculate the set subnetwork address, the usable host addresses, and the subnet broadcast addresses for a network. Correctly and, okay, AND, it's a function, and a destination IP address and the subnet mask, which is what the router does, so we can make a decision on what is the best path to take. Where do I send this data? And remember, routers don't care about getting the data to you. Routers only want to get it to your network, and then your switch will then get it to you. So you have to set up these intermediary devices accordingly. So let's look at the first scenario. The Crazy Guys cable company needs their network subnetted to help the organization, or to help organize a network. They need at least 5 subnets, okay, for their network. The network number of their network is 195.40.25.0. Let me go ahead and grab my trusty Sharpie. Better use a dry erase pen here. Okay? It would probably get upset if I wrote in a Sharpie on the board, right? As always, on the right-hand side of your paper or across the bottom, go ahead and do your powers of 2. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. You can keep on going and going and going and going. You don't have to. So we know we have 195.40.25.0. That is the network number. Okay? We know that it is a Class C because it falls in my Class C range. Okay? At this point, it is one single network. We want it to have at least 5 networks. So we look over here in our right-hand column and we have to make a determination. Which number over here will encompass the 5 networks without going too crazy and over and above the call of need here? And we'll say, okay, 2 doesn't cover it, right? 4 doesn't cover it. 8 covers 5, yes. 16 does also, but that's going over and above. So let's go ahead and look at that. 8 bits. 2 to the what equals the 8? 1, 2, 3. It's the third number down. All right, so 2 to the third. So that means we're going to borrow 3 bits to get the 8 networks here. So my subnet mask by default was a 255.255.255. I've got 8 bits, 2, 3, 4, 5, 6, 7, 8. I have 8 bits that I can play with. Okay? The rule says I borrow from left to right to create networks. Okay? So left to right, I have to turn on or borrow 3 bits. So I'm going to borrow these 3 bits. 1, 2, 3. So I borrowed those 3 bits. Okay? That just gave me my new subnet mask, because right now my subnet mask, okay, is 255, 255, 255, 128 plus 64 plus 32. Those are the bits that I turned on. Remember, don't forget that each one of these has a bit, has a point value. 128 points, 64 points, 32 points, 16 points, 8 points, 4 points, 2 points, 1 point. We turned on these 3, the 128, the 64, and the 32. That equals 224. I borrowed 3 total bits. There was 24 here, plus 3. 24 plus 3 is 27. I created a total number of 8 bits because I borrowed 3. 1, 2, 3. So I created, so I created 8 total networks. Right? I did not borrow 1, 2, 3, 4, 5. I did not borrow 5 bits. There's 2 ways that I can come up with that number. I can look at the right hand side of my paper and say 1, 2, 3, 4, 5, and then I created 32 hosts in that network. Okay? Or you can look at it and say, what is the last point value that I turned on? 128, 64, 32. The last bit I turned on was the 32-bit value, which is the total number of hosts. Can't use the first, can't use the last. 30. So now let's go ahead and figure out this table, because we got it all started, okay? So my subnet number 0, the first subnet, okay, is going to be 195.40.25.0. See, if I were to do an ANDing operation, okay, in AND the subnet mask, okay, with the network number, that's the number I'm going to get, which happens to be the first usable network on my network, okay? Then I want to say, all right, the last number I turned on was 32, right? So that's also going to be the next network number. So the way it works is each network has to be incremented. So what's my next network? So the last significant bit that I turned on was the 32-bit. Okay? So my networks are going to increase by 32 in that last octet where I'm working right here. Okay? So another way to look at it would be this. I can make a borrowing line right here. Okay? So I AND it, and I end up with a 192.40.25. Okay? That's my first network right here. The first host on network 0, okay, is 195.40.25.1. So if I was counting up in binary, it would look like this. The 1 would be turned on. That's the first host on my network. The next one would be this. That's 2. Then it's going to be that's 3, because this is the 1, that is a 2, 2 plus 1 equals 3. Then it's going to be like this. 4, 5, and we're going to keep on counting. We're going to have 32 total rows of binary computation until it looks like this. until I fill up everything on the right-hand side of my borrowing line. Okay? That equals 31. That means I'm speaking to everybody on my network. And that's called my broadcast address. One number less than that is 195.40.25.30. So that means my range, my network number is at 25.0. My range of usable hosts in here is 195.40.25.1 all the way to 195.40.25.30. The broadcast address for that, the other one that I cannot use, is 195.40.25.31. We add one number to that, we add one number to 31, and it looks like this. The 32-bit jump. Had a little technical difficulty there. I had to do another section of this video because my battery ran dead on the GoPro. But looks like we're okay right now. So where I had concluded before was, as I got to, actually would have been right here. Once I filled in all ones right there, I equal 31. In order for me to go to the next network, which will be my 32, okay? Actually, let me erase this real quick. And we'll do the whole thing together as a group. All right. Sorry about that. Now, so the next step would be to go to 32 because I need a new network. So on this side of my borrowing line is where I have my networks, okay? Over here is my host. This is my sub-network group right here, my host group over here. The next smallest number that I can create on the left-hand side of my borrowing line, this line here, is the 32 column, right? So my new network goes 195.40.25.32. Okay? So we're going up in increments of 32. So the first number, usable host I can get off of that is 192.40.25.33. 1 plus the 32. Then 195 to 40 to 25. Okay, I have to have a range of usable hosts here in the center. So if I take this number here and I bump it up by 32, 31 plus 32 is 63. One minus the 63 is 62, which brings us to a very important part right here, and that is that network numbers are always even numbers. The first usable host is always an odd number. The last usable host is always an even number. And the broadcast number is always an odd number. And if you take a look, they're all going up by 32 points each time. Each column is consistent with that 32-point increase, okay? And it's just going to work the same way again. I have my 32, 33, 34, okay? And we're just going to keep counting up and keep this pattern going all the time until we come up with all ones again over here on the right-hand side of my host field, okay? And then the next number up, okay, after this, because I just hit 63, is going to be 64. And that pattern is going to continue, and I'm going to show you how we do it. You don't have to keep doing it in binary. You'll run out of paper after a while. But I'm going to show you how we do it here on the table, okay? 195.40.25 plus 32 is my 64, which you can see in the binary table, okay? I have a habit of going over here on I work predominantly with my network column first, and I do my 25, add 32, I have 96. 195.40.25, add 32, I have 128. Okay? 195.40.25. Now I bump up to 160. 195.40.25. Now I bump up to 192. 195.40.25.224. That's a very significant number right now. This is as far as I can go. I created 8 total networks, right? 1, 2, 3, 4, 5, 6, 7, 8. How do I also know it's the end? You see this number here, the network number? It matches my subnet mask number. So then I'm going to come over here and say, all right, so this column over here, for my last broadcast number, is going to be, 195.40.25.255. The usable range here is going to be 195.40.25.254, always one less. And this guy's going to be one more at 195.40.25.225. So that's my usable range right here. And what makes it easy for me, I say, okay, well this guy right here is 224, so this guy's going to be 223. This guy is 192, so he's going to be a .191. This guy is 160, so he's going to be a .159. This guy is 128, so he's going to be a 127 over here. This guy is a .96, so he's going to be a .95. Then you just fill in everything else on your table to work. Then all I got to do is jump over to my usable range, and that's an important piece right there, because that's what you get to dole out to your servers, to your printers, to your host, your DHCP table, everything, okay? So we have to make sure that that is always going to be right. So now I got my broadcast column, my network column, my ranges are just in between. So this guy here, please excuse me, I'm not going to write out 192.40.25 and all of these. This guy's going to be a .65 all the way up to a 94. This guy's going to be a .97 all the way up to a .126. This guy's going to be a .129 all the way up to a 158. And the last one here is a 161 all the way to a 190. Okay? And then we have a 193 all the way to a 222. So now we have our table completed, we have our ranges completed, but there is one last section that they have on this table that they would like us to complete. And it is what occurs when your router does what's called an ANDing operation. When your router gets a packet, your packet has to go to one of these networks. It needs to know, how do I know which network to send it to? Does it just throw it to the router and let the router just like try one, try one, try one, try one? No, the routers are smarter than that. So, if it's okay, I'm going to go ahead and erase this table here on the side. Ooh, that's weird. Clean that then, but all right. it says, I have a packet addressed to 195.40.25.189. How do I know what path to send it? How do I know what interface to send it out to? How do I know what network it belongs to? Routers don't have this table just sitting there. Routers just do the math. The router looks at the IP address and the subnet mask, and then makes its ANDing operation. So let's go ahead and do that. I've got the subnet mask already done for us. It's a 255.255.224. Now we're going to put up on the board the 195.40.25 .189. So let's break the 189 down into binary. And if for those of you who don't remember how to do that, we're going to take our 189 points right here, okay? And we're going to just come over to the first left column, which is 128 points, and just ask yourself some simple questions. Does 128 go into 189? The answer is yes. So, true, you make it a true, and then you subtract the 128 from the 189, which gets us 61 points, all right? Now, next question. This is the 64 column here. Does 64 go into 61? Well, the answer is no. So, that's a false. We put a 0 there. Does 32, next column, does that go into 61? The answer is yes. So, we're going to subtract the 32 out of that, mark that as true, and we have 29 points remaining, okay? Does 16 go into 29? Yes, it does. So we're going to mark that as true, subtract that one out, gives us 13 points remaining, okay? Does the 8 go in there? Yes, it does. That leaves us 5 points remaining. The 4 goes into that with the 1 remaining, so the 2 doesn't go in, the 1 does. So that's 189 represented in binary. Then we're going to do a simple ANDing operation, which is what the router does. The 195 will come down, the 40 will come down, the 25 will come down, then we're going to bring this one down. Okay, the 128 comes down, the 64 does not, the 32 comes down, and then all of these, okay, are going to end up being false as well. I wrote the 3. That's funny. And 1 comes down there. So now I add these up. 128 plus 32 equals 160. That means that the 189 address belongs on the 160 network. Now we can go ahead and double check that by looking at our table, and we can see that 160 goes all the way to 191. And 189 is in between, it's inside of our usable ranges. So that's the action the router takes. So now I hope you got some good information out of that. I hope I got it all pieced together properly for us after the battery went dead on the GoPro. And go ahead and finish the next part of your assignment. And we'll talk to you soon.